Hi everyone, and we have completed successfully the 3 lectures, right? So that is on basics of vectors. Now here this is lecture number 4, and here we are going to start a new topic that is coordinate systems. So the third chapter, that is coordinate systems, right? So the first chapter we have completed, that is introduction, and the second chapter, that is basics of vectors, and after that we have started what? We have started coordinate systems. This is the third chapter, and this is lecture number 4, right? Okay, right. So first of all, here coordinate systems. So what is the purpose of coordinate systems here? What is the purpose of coordinate systems? See, the purpose of coordinate systems is with the help of coordinate system we can represent the distribution of the fields in 3-dimensional space, right? See, for example, if you consider an antenna, so that antenna is going to radiate the electromagnetic waves in 3-dimensional space. So if you want to represent the distribution of these fields that are radiated by the antenna in 3-dimensional space, then we can represent them in a simple manner with the help of what? With the help of the coordinate systems. So that is the purpose of the coordinate system. So with the help of coordinate systems we can easily represent the distribution of the fields in 3-dimensional space. So that is the purpose of coordinate systems. So in coordinate systems we are having 3 types of coordinate systems here. We are going to study 3 types of coordinate systems. So the first one is a rectangular coordinate system, or we can call it as Cartesian coordinate system. So here the coordinates are nothing but x comma y comma z, and the second one is a cylindrical coordinate system, and the coordinates are nothing but rho comma phi comma z, and the third one is a spherical coordinate system, and here the coordinates are nothing but r, theta and phi. Okay, so these are the 3 types of coordinate systems that we are going to study in our subject, right? Okay, so one is rectangular, and the other one is cylindrical coordinate system, and the third one is spherical coordinate system. So I hope you are very much familiar with this rectangular coordinate system. So we'll just go briefly about this rectangular coordinate system. So we'll study in depth of this cylindrical and spherical coordinate system. So each and everything we will study in detail, but what I am saying here is a rectangular coordinate system or Cartesian coordinate system you are very much familiar. Understood? Okay, so that's why we will spend some less time in rectangular coordinate system when compared to what? When compared to other coordinate systems, right? Okay. So all these 3 coordinate systems, are called as a right-handed, are called as what here? Are called as a right-handed orthogonal coordinate systems. All these 3 coordinate systems are called as what? Are called as right-handed orthogonal coordinate systems. So here the first one, why we are calling it as orthogonal? Why we are calling it as orthogonal coordinate system? So why means here, if you observe in rectangular coordinate system, this x, y and z, all these 3 coordinates are orthogonal to one another, or I can say mutually perpendicular to one another. And if you consider cylindrical coordinate system, this rho, phi and z are mutually perpendicular to one another. And in spherical coordinate system, these coordinates r, theta and phi are mutually perpendicular to one another. Since in all the coordinate systems and all the 3 coordinates are what? Are mutually perpendicular to one another, and hence we call these coordinate systems as what? As orthogonal coordinate systems, right? Okay, so I hope it is crystal clear. Now comes the question, why we are calling it as right-handed? What is the reason behind that? See here, whenever we are drawing the coordinate axis, we are going to follow this right hand rule. We are going to follow a right hand rule whenever we are drawing the coordinate axis. So that's why we call it as right handed coordinate system. Okay, so overall we call all these coordinate systems as a right handed orthogonal coordinate systems. Okay, so what is this right hand rule and how to follow this one? So all those things we will study, right? Okay, so now see here. So here you have understood that why we are calling them as orthogonal coordinate systems. Now we will see why we are calling them as right handed. So I said that here whenever we are drawing the coordinate axis, you have to follow a right hand rule. Okay, so what is that right hand rule or what is that right handed convention we have to follow? Okay, so that's what I am going to explain here. So here just draw a table like this. So x, y and z. So just form a box here, not table, it is just a box. Okay, so this I am calling as a right hand convention. This is the right hand convention or right hand rule that we have to follow, right? Okay, so what do you mean by that? See here. So now you can take any two coordinate axis here. You can take any two coordinate axis as you wish. So let us consider x axis here. I am considering x axis here and y axis here, right? Okay, so I have considered two coordinate axis, x axis and y axis, and the third coordinate axis is nothing but what? Is nothing but z axis, isn't it? Okay, so now z axis must be perpendicular to both x and y. So I can draw the z axis either out of the board or I can draw the z axis into the board, right? But in which direction I have to draw the positive z axis? In which direction this third positive coordinate will point? Okay, that's what I want to determine. So that we can determine by this right hand convention. So what this convention is saying here is here you have taken x axis and here you have taken y axis, right? So always you have to curl the four fingers of your right hand from x to what? Whenever you are having x and y axis, you have to curl the four fingers of your right hand from where to where? From x to y. So if you curl your four fingers of your right hand from x to y, then the thumb is going to give you the direction of the third positive coordinate. Understood? Okay, so this is called as right hand convention. So you should not draw the third positive coordinate as you wish here. You have to follow the right hand convention while drawing the third positive coordinate. Understood? So here you have to curl your right hand fingers from where to where? From x to y. So take your right hand. So this is x axis. So curl your four fingers of your right hand from x to y. Then the thumb is pointing out of the board. So that means the third positive coordinate is going to point out of the board. So I have already explained this symbol represents what? This symbol represents the vector pointing out of the board. See, if you throw an arrow here, if you are having an arrow, okay, so if you throw the arrow that means if you throw the arrow towards you, okay, if I throw the arrow towards you, what you are going to see? You are going to see this tip of the arrow. That means you are going to see this dot. So if the arrow is coming towards you, okay, you are going to see this tip of the arrow. And if the arrow is going away from you, then you are going to see this into mark. Understood? So that's why if you represent a dot here enclosed by a circle, this represents the vector is pointing out of the board. That means the arrow is coming out of the board. Whenever the arrow is coming out of the board, you are going to see the tip of the arrow, that is nothing but dot. Okay, so this convention represents the vector is pointing out of the board. And if I represent a circle, so inside a circle if I put a cross mark, then it represents the vector that is pointing into the board. So if the arrow is going away from you, you are going to see this into mark. Understood? This is the convention to represent the vector that is coming out of the board and going into the board, right? Okay, so I hope this is crystal clear. right? Okay. Okay, so here z-axis is coming out of the board. Now I will give you some examples. You have to tell me the direction of the third positive coordinate axis. So this is first one, right? Next, second one. So let us consider here, this is y-axis, right? And this is z-axis. You have to tell me the third positive coordinate direction. Here the third positive coordinate is nothing but what? Is nothing but positive x. So you have to tell the direction of positive x, whether it is out of the board or into the board. Okay, so do it here, do it, right? Next, third one, third example I am considering. Let us say this is x-axis and let us say this is z-axis, right? And the fourth one, let us say this is y-axis and this is z-axis. Okay, so I have taken some few examples. So here you have to tell me the third positive coordinate direction, right? Okay. Okay, so let us consider here, this axis as x-axis, right? Okay. Okay, so now tell me what is the direction of the third positive coordinate here. See, here you have taken two coordinates. What are the coordinates? Y and z, right? So if you are having y and z here, you have to curl your right hand fingers from where to where? From y to what? From y to, if you are having y and z, you have to curl your right hand fingers from y to what? From y to z. So from y to z, right? So take your right hand fingers, curl your right hand four fingers from y to z. So the thumb is pointing out of the board. So that means here the x-axis, the positive x-axis is pointing out of the board, right? Next, coming to this one. Here you are having z-axis and x-axis. So whenever you are having z-axis and x-axis, you have to curl your right hand four fingers from where to where? From z to x. So that means you have to curl your four fingers from z to what? From z to x. So if you curl your four fingers from z to x here, so the third positive coordinate, that is y, has to point in which direction? Out of the board. So here also it is what? It is out of the board, right? Okay, next, coming to here y-axis and here x-axis. So whenever you are having x and y, you have to curl your right hand four fingers from x to what? From x to y. So if you curl your four fingers from x to y, what you are going to get? The third positive coordinate will point in which direction? Out of the board. So that means here the z-axis is also what? Is also pointing out of the board. So in all the three problems, the third positive coordinate is pointing out of the board. So in this manner you have to draw the coordinate axis here. Whenever you are drawing the coordinate axis, consider two coordinate axis as you wish. You can take two coordinate axis as you wish. So in order to determine the third positive coordinate direction, you have to follow this right hand rule. Okay, you should not take the coordinate axis as you wish. You have to follow this right hand convention. So that's why it is called as a right-handed orthogonal coordinate system. See one last example here. Let us take this as a x-axis, right, and this as a y-axis. So what is the direction of z-axis here? What is the direction of z-axis in this case? So here you are having x-axis and y-axis. So you have to curl the four fingers of your right hand from where to where? From x to y. So if you curl your four fingers from x to y, then the thumb is pointing into the board. So in this case, the z-axis has to point into the board. So in this manner, we have to choose the, or in this manner, you have to draw the coordinate axis. Understood? So this is called as a right hand convention, right? Okay, so you have to follow this right hand convention, right? Okay, okay. Okay, so if you draw in this manner here, now you can check if you do z bar cross x bar, if you if you curl your fingers from Z to X, then the thumb is pointing in Y direction, isn't it? So if you curl your fingers from X to Y, the thumb is pointing in positive Z direction, isn't it? Okay. Okay. And if you curl your fingers from Y to Z, the thumb is pointing in X direction. So everything will be what? Everything will be satisfied. Everything will be satisfied. Okay. So you can curl once you follow this rule. Okay. Then if you curl your right hand four fingers, according to this convention, that is, if you curl your right hand four fingers from X to Y, then the thumb has to point in positive Z direction. If you curl your four fingers from Z to X, then your thumb has to point in positive Y direction. Understood? If you curl your four fingers from Y to Z, then your thumb has to point in positive X direction. So this will be satisfied. Understood? Okay. Always this right hand convention has to be satisfied, right? Okay. So whenever you are drawing the coordinate axis, what you will do, just draw the two coordinate axis as you wish here, understood? But while drawing the third coordinate axis, follow this one, understood? Okay. Follow this right hand convention, right? Okay. So I hope it is crystal clear here. Right. Okay. Next. So next we will start with a rectangular coordinate system. First we will start with rectangular coordinate system. We can call it as rectangular coordinate system or Cartesian coordinate system. The coordinates are nothing but x, y, z. The coordinates are nothing but x, y, z. Okay. So here I am drawing the three coordinate axes. Let us say this is x axis. Let us say this is y axis. And let us say this is z axis, right? Okay. So this is x axis, this is y axis, and this is z axis, right? So if you do x cross y, okay, so that means if you curl your four fingers, right hand four fingers from x to y, the thumb is going to point in upward direction. Okay. So the right hand convention is satisfied here, right? Okay. So this is x axis, y axis, and z axis, right? Okay. So now see here. So now if I represent a point here, suppose I am representing a point here. So let us say this point is let us say x, y, z. Let us say this point is x, y, z. Understood? Okay. So now here we are going to measure or we are going to represent any point here, any point in the rectangular coordinate system with respect to what? With respect to origin. So we will consider this origin as what here? We will consider this origin as a reference point, our reference point. Okay. So we measure any point in three-dimensional space with respect to what? With respect to origin. Here this point we have represented with x, y, z. So what do you mean by x here? So that means along x direction, the distance from the origin is nothing but what? X units. Okay. Y means what? Y means the distance from the origin along y axis is y units. Z means the distance from the origin along z direction is z units. That's what this point represents. Understood? Okay. Okay. So now see here. Now if I draw a vector that is pointing from origin, to this point, okay. So I am representing a vector, I am drawing a vector that is pointing from origin to this point. So this is generally some point, some arbitrary point I have chosen. So the vector that is pointing from origin to any point in three-dimensional space, we call it as a position vector, which is represented by r bar. So r bar generally we call it as what? We call it as a position vector. We call it as what? Position vector. So this is the vector that is pointing from the origin to any point in three-dimensional space. Understood? So why we are calling it as position vector here? Because it is going to give you the position of any point. It is going to give you the position of any point measured with respect to what? Measured with respect to origin. See, if I consider one more point here, let us say this is x1 comma y1 comma z1, then the position vector will be from where? From the starting point of the position vector will be always same, that is origin. Okay, so from origin to this point, if I draw a vector, so I can call this as position vector. Let us say this is r1 bar. So this r1 bar is called as position vector. So what is the purpose of position vector here? It will give you the position of any point. It will give you the position of any point that is measured with respect to what? It is measured with respect to origin. Okay, so the position of any point measured with respect to origin is given by what? Is given by the position vector. Understood? Okay. Okay. So it gives you the position of any point with respect to origin. So that's why it is called as position vector. Position vector. Okay. Why it is called as position vector? It measures, or I can say it gives the position. It gives the, or I can say simply it measures the position of any point with respect to what? So it measures the position of any point. It measures the position of any point in 3D space with respect to what? With respect to origin. So that's why it is called as what? It is called as position vector. Understood? Okay. So here this position vector is neither along x-axis, nor along y-axis, nor along z-axis. In that manner I have chosen this position vector. Understood? So this position vector is neither along x-axis, nor along y-axis, nor along z-axis. So I have already discussed that if the vector is neither along x, nor along y, nor along z, then that vector is going to have its components along those reference axes. Yes or no? Here what are the reference axes? X-axis, y-axis and z-axis. These three are the reference axes. Here I have considered a vector which is neither along our three reference axes, which means this vector is going to have its components along those reference axes. Now, how we can determine the components of this vector along this reference axis here? What you have to do? So here what you have to do here is just to drop a normal. So here now here just drop a normal, from the head of r bar onto what? Onto xy plane, right? Okay. Now draw a vector from origin to this point. Understood? Okay. Now this vector can be resolved into what? Now this vector is in xy plane. Yes or no? Now this vector can be resolved into two components. One is along x direction, right? One is along x direction and another one is along y direction. Right? Okay. So this is called as a x component and this is called as what? This is called as a y component. Okay. Okay. So what I have done here? I have dropped a normal from the head of r bar onto what? Onto xy plane. So now I have drawn a vector from origin to this point. Now this vector can be resolved into what? Two components. One is along x direction, another one is along y direction. Understood? So this is called as x component and this is called as y component. Or you can say this is y component, yes or no? And this is x component. Both are same here. Okay, these two are parallel, right? And in order to get the z component, what you have to do? Just drop a normal from the head of r bar onto what? Onto z bar, Okay, the distance from here to here, the distance from here to here is called as what? Is called as z component. Is called as z component. Understood? Okay, so this x component value is nothing but what? X. This y component value is nothing but y, and this z component value is nothing but z. So we can represent this r bar. We can represent this r bar in this manner. So that is r bar is equal to what? Is equal to x ax cap plus what? Plus y ay cap plus what? Plus z az cap. So x represents what here? X represents here x component, and here y represents the y component, and this z represents what? This z represents the z component. Understood? So since r bar is neither along our reference axis, it is having its components along those reference axis. So the component of r bar along x direction is x, and the component of r bar along y direction is y, and the component of r bar along z direction is z. Understood? So it is having all the three components, right? Okay, okay. And also we know one more thing, that is if you are having b bar, right, and here you are having a bar, and if you know the angle between these two vectors here, if you know the angle between these two vectors, let us say theta. Now if I ask you what is the component of a bar along b bar, what is the component of a bar along b bar here? That is nothing but a into cos theta. Yes or no? Or if I ask you what is the component of b bar along a bar, what you will tell? You will tell it as b cos theta. Similarly, if I take some c bar here, and here some vector d bar, and if I know this angle theta, then if I ask you the component of c bar along d bar is nothing but what? Is nothing but c cos theta. The component of d bar along c bar is nothing but what? Is nothing but d cos theta. Yes or no? So in this manner you can easily tell the component of one vector along the other. Directly you can tell the component of one vector along the other if you know the angle between those two vectors. Understood? Okay, okay. So now let us assume here this r bar, that is position vector, making an angle of phi x with respect to what? With respect to x axis. Let us assume it is making an angle of phi x with respect to x axis. Okay, phi x with respect to x axis, and it is making an angle phi y with respect to y axis, right, and it is making an angle phi z with respect to z axis. Okay, then in that case, how we can represent this position vector in terms of this phi x, phi y and phi z, right? See, just now I have told here, if you are having any two vectors, and if you know the angle between those two vectors, then we can easily tell the component of one vector along the other. Yes or no? Just now we have seen, if you are having a bar and b bar, and if the angle between a bar and b bar is theta, and if I ask you the component of a bar along b bar, that is nothing but what? A into cos of angle between a bar and b bar, that is a cos theta. Understood? Similarly here r bar. So this r bar is going to have what? This r bar is going to have x component. So the x component is all pointing in x direction, right? Next you are going to have y component, that is pointing in y direction. Next you are having z component, that is pointing in z direction, that is going to point in z direction. Now you have to, what I am asking here is you have to write the x component, y component and z component in terms of angles, okay, okay. Now here you know the angle between r bar and x axis, you know the angle between r bar and x axis. So what is the component of r bar? The component of r bar along x axis is nothing but what? Is nothing but x component. Yes or no? The component of r bar along x axis is nothing but x component. So what is the component of r bar along x axis here? Is nothing but what? Is nothing but r cos phi x. Yes or no? Okay, I hope it is crystal clear. Similarly, what is the component of r bar along y direction here? What is the component of r bar along y direction? The component of r bar along y direction is nothing but what? R cos phi y. Yes or no? So that is nothing but r into cos phi y. And what is the component of r bar along z direction? Is nothing but what? R cos phi z. So r cos phi z, r cos phi z. Understood? So this is how we can represent the position vector. This is how you can represent the position vector in terms of what? In terms of angles. So if you know the angle made by the position vector with respect to x-axis, y-axis and z-axis, then we can represent the position vector in terms of angles in this manner. Okay, so r cos phi x represents the x component of r bar along x, r cos phi y represents the component of r bar along y, r cos phi z represents the component of r bar along z. Okay, okay, right, fine. So I hope it is crystal clear. Now see here, now here I can take r common, yes or no? From these terms I can take r common. So if I take r common and send that r to LHS side, I can write it as what? I can write it as r bar divided by r. Okay, so which is equivalent to what? Which is equivalent to cos phi x ax cap plus what? Cos phi y plus what? Cos phi y ay cap plus cos phi z az cap. So r bar divided by r. So this r is nothing but what? This r is nothing but magnitude of r bar. Yes or no? So I can write this as this r is nothing but what? Magnitude of r bar only. Right? Okay. So this r bar divided by magnitude of r bar is nothing but what? Is nothing but the unit vector along r bar. Unit vector along r bar. So that means the unit vector along the position vector, or I can say the unit vector along r bar, you can represent it as what? Ar cap is equal to what? Is equivalent to cos phi x ax cap plus what? Plus cos phi y ay cap plus what? Plus cos phi z az cap. So that means if you know the angle made by a vector here, if you know the angle made by a vector with respect to x-axis, y-axis and z-axis, then you can directly tell the direction of that vector in terms of this cosines. Understood? Okay. So that's why this cos phi x, this cos phi z, cos phi y and this cos phi z are called as what? Are called as a direction of what? Direction of cosines. We call it as direction of cosines. So if you know the angle made by a vector with respect to x-axis, with respect to y-axis and with respect to z-axis, then you can tell the direction of that vector in terms of cosines. Right? See, unit vector will always gives you what? Unit vector will always gives you direction. Yes or no? So we can tell the direction of any vector in terms of what? In terms of cosines. So that's why it is called as what? Direction of cosines. It is going to give you that's why it is called as direction of cosines. Okay, it is going to give you the direction of the vector. So if you know the angle made by the vector with respect to x-axis, y-axis, z-axis, then you can directly tell the direction of the vector in this manner. Understood? Okay, okay. So since we are representing the direction of the vector in terms of what? In terms of cosines, we call it as direction of cosines. Right? Okay. So from here we can get one more condition. So that is, we know that the magnitude of ar cap here, this is unit vector, isn't it? Right? So the magnitude of unit vector must be always equivalent to what? Must be always equivalent to 1. So what is its magnitude here? So magnitude of ar cap is nothing but what? Square root of cos square phi x plus what? Cos square phi y plus what? Plus cos square phi z. So this is equivalent to what? This is equivalent to 1. So if you square on both sides, what you are going to get? You are going to get cos square phi x plus what? Plus cos square phi y plus what? Plus cos square phi z is equal to what? Is equal to 1. Right. So this is the condition we got here. This is the condition we got. Right. Okay. So always cos square phi x plus cos square phi y plus cos square phi z must be equal to what? Must be equal to 1. Must be equal to 1. So this is the condition we got, isn't it? Okay. Okay. So now see here. Now just write down a problem here. Now just write down one problem. So let us take a vector. Let's consider a vector A bar is making an angle phi x is equal to 30 degrees with respect to x axis, and phi y is equal to 45 degrees with respect to y axis. Then determine the direction of A bar. Determine the direction of A bar. Right? Okay. So this is the question they have given. So what is the solution for this one? Tell me, what is the solution for this one? So what they have given, let's consider a vector A bar, and this vector A bar is making an angle phi x equal to 30 degrees with respect to x axis, and phi y equal to 45 degrees with respect to y axis. Then determine the direction of A bar. So if you want to determine the direction of A bar, okay, so here they have given the angles with respect to x axis and y axis. We don't know the angle with respect to z axis. Understood? So if you determine this phi z here, then you can write the direction along A bar. So that is nothing but AA cap. This will give you the unit vector along A bar. So that is the direction of A bar. So I can represent the unit vector in terms of what? In terms of cosines. So that is cos phi x AX cap plus what? Plus cos phi y AY cap plus what? Plus cos phi z AZ cap. Okay. So here this is the unit vector here. This is the unit vector along A bar. Here we know phi x and here we know phi y. So phi x is nothing but how much here? 30 degrees, and phi y is how much here? Is nothing but 45 degrees. So we don't know phi z. So you have to determine phi z. Okay. So we know the condition here. What is that condition? Cos square phi x plus what? Plus cos square phi y plus what? Plus cos square phi z must be equal to what? Must be equal to 1. Right. So phi x is nothing but 30 degrees. So cos square 30. So cos square 30 degrees plus cos square 45 degrees plus cos square phi z must be equal to 1. Is equal to 1. Right. Okay. So if you do this, what you are going to get? Cos 30 is how much here? Root 3 by 2. So that means you are going to get cos square means here you are going to get 3 by 4 plus cos 45 is 1 by root 2. 1 by root 2 whole square is nothing but plus 1 by 2 plus what? Plus cos square phi z is equal to what? It is equivalent to 1. So therefore what you are going to get? Cos square phi z is equivalent to 1 minus of 3 by 4 plus 1 by 2. Okay. So that is equivalent to 1 minus of, okay, so 4 here, 3 plus 2. So 1 minus 5 by 4 here. This is equivalent to 1 minus 5 by 4. Right. So right now, right. So 1 minus 5 by 4. So that is 4 minus 1. 4 minus 5, that is minus 1 by 4. Right. So that is wait. Cos square 30 degrees, cos square 45, root 3 by 2 is 3 by 4, 1 by 2, right. Okay. So 1 minus root 3 by 2. Right. Okay. Wait here. So here we are getting a cos square value as negative. Okay, so but this is not valid, right? Okay, so just since I have taken the values randomly, we got something wrong. Okay, so just change this values here, so here 5x is equal to 30 degrees, and here let us consider 5y is equal to 60 degrees, right? Okay, so in that case what you are going to get, 5x is 30 and 5y is 60, right? Okay, so then in that case here this will be what, 5y is 60 degrees, right? Okay, so cos square 60 degrees, right? So change this problem here, so just change the angle here, consider 5y equal to 60 degrees and 5x is equal to 30 degrees, right? Okay, so cos square 30 plus cos square 60, so that is 3 by 4 plus what, plus 1 by 4 plus what, plus cos square 5z is equal to what, is equal to 1. So 3 by 4 plus 1 by 4 is nothing but what, 1. So 1 plus cos square 5z is equal to 1. So cos square 5z is equal to 0. So this implies 5z is equal to what? 5z is equal to 90 degrees. 5z is equal to 90 degrees, right? Okay. So 5z is equal to 90 degrees, right? So therefore a bar, therefore the direction of a bar, a cap is equivalent to what? Is equivalent to cos 5x ax cap plus what? Plus cos 5y ay cap plus what? Plus cos 5z az cap, right? Now here 5x they have given 30 degrees and 5y they have given 60 degrees, right? So what you are going to get? You are going to get root 3 by 2 ax cap plus 1 by 2 ay cap plus 5z, what we got? 5z we got 90 degrees, so that means this is 0 az cap. So the direction of the vector a bar is nothing but what? Root 3 by 2 ax cap plus what? Plus 1 by 2 ay cap, right? Okay. So this is the answer for this question, right? So previously I have taken some random value, so that's why we got some wrong result. So okay, so change these values here, so 5x is equal to 30 and 5y equal to 60 degrees. So in this case what is the direction of a bar we are getting? The direction of a bar will be equivalent to what? Will be equivalent to root 3 by 2 ax cap plus 1 by 2 ay cap. So this is the answer for this question, right? So with this we have completed this problem, right? Okay. So in the next lecture, so with this I am winding up this session here. So in the next lecture again we are going to continue with this rectangular coordinate system. Understood? Okay, so we will continue this rectangular coordinate system in the next lecture. So I am winding up the session with this, right? Okay, so thank you for watching. Take care. Bye bye.